Dear friends, in today's video, I am going to teach you how to find out the charge on capacitors connected in parallel combination and how to find the charge on every capacitor connected in the series combination. Here I have taken one parallel circuit in which the capacitors are connected in parallel. In second example, I have taken the three capacitors connected in the series combination, and I will be teaching you how to find the charge on these three capacitors and here in the series combination as well as. In this diagram, we got the three capacitors. First is a 3 picofarad, second one is a 4 picofarad, and third one is a 5 picofarad. They are connected in parallel, and this parallel combination is connected across the 100 volt supply. What we have to do, how much charge on the first capacitor, how much charge on the second capacitor, and how much charge on the third capacitor, that we need to find out. So we need to find Q1 equals to question mark and Q2 equals to question mark and Q3 equals to question mark. So whenever the capacitors are connected in parallel, how to find their combination? So first call this as a C1, call it as a C2 and call it as a C3. They are connected in parallel, so C equivalent can be denoted by Cp, that is a combination of three capacitors C1 plus C2 plus C3. This is the formula for finding the equivalent capacitance when three capacitors are connected in parallel. So Cp equals to 3 plus 4 plus 5, that equals to 12 picofarad. So the equivalent capacitance of the combination is 12 picofarad. What we need to find? We need to find charge on the first capacitor, charge on the second capacitor, and charge on the third capacitor. Now, the charge on the first capacitor, that is Q1, can be obtained by using the formula C1 multiplied by V, and the charge on the second capacitor can be obtained by formula Q2 equals to C2 into V, and the charge on the third capacitor can be obtained by Q3 equals to C3 into V. What is the V? The V is nothing but applied potential, because they are connected in parallel, so the potential between the plates of each capacitor equals to applied voltage. Applied voltage how much? 100 volts. Therefore, at each capacitor the potential difference is equals to 100 volts. We have C1 equals to how much? 3 picofarad. So first convert into farads. 3 into 10 raised to minus 12 farads. Then after that C2, that is 4 picofarad. So that is equals to 4 into 10 raised to minus 12 farads. Similarly, C3 equals to 5 picofarad. So that is equals to 5 into 10 raised to minus 12 farads. Now, charge on the first capacitor Q1 equals to C1 into V. What is the C1? C1 nothing but 3 picofarad. That is a 3 into 10 raised to minus 12 farad, and applied potential, applied, that is 100. So this is equals to 3 into 10 raised to minus 10 coulombs. Similarly, charge on the second capacitor Q2 equals to C2 into V. What is the C2? 4 into 10 raised to minus 12 farad, and applied potential is 100. So that is equals to 4 into 10 raised to minus 10 coulombs. Similarly, charge on the third capacitor Q3 equals to C3 into V. What is the C3? That is 5 picofarad. That is a 5 into 10 raised to minus 12 farad. Applied potential is 100. This is equals to 5 into 10 raised to minus 10 coulombs. Here we have the three capacitors. They are connected in series. Now we have to find the charge on each capacitor and total capacitance of the combination. The combination is connected across 100 volt supply. So step 1, to find total capacitance, that is 1 upon C equals to 1 upon C1 plus 1 upon C2 plus 1 upon C3. the C is given by C1 into C2 into C3 divided by C1 C2 plus C2 C3 plus C3 C1. Therefore, C equals to 2 into 3 into 4 upon 2 into 3 plus 3 into 4 plus 4 into 2. This is equals to, that is a 624 divided by 6 plus 12 plus 8. So that is 24 upon 26. So this is equivalent capacitance of combination and it is a picofarad. We have answered the first question, how to find out the equivalent capacitance in the series combination. Now second is, we need to find charge on the each capacitor. Now formula for the charge is nothing but C1 into V, that is the charge on the first capacitor, charge on the second capacitor C2 into V, and the charge on the third capacitor, that is C3 into V. The potential, since they are connected in series combination, so the charge on every capacitor is same, it is not different. Therefore, to find out the charge on every capacitor, we cannot use this formula, but we have to use the here equivalent capacitance, that is CS. We have the CS value 24 upon 26 picofarad multiplied by V, that is Q1 equals to CS into V, Q2 equals to CS into V, and similarly Q3 equals to CS into V. Therefore, for parallel combination, we cannot use this formula because they are in series combination. Charge on the every capacitor will be the same. So to find the charge on the every capacitor, only one formula, that is the equivalent capacitance of series combination multiplied by applied potential. Therefore, one thing you keep in your mind, in series combination, charge on the first capacitor equals to charge on the second capacitor equals to charge on the third capacitor. So Q, that is we find the Q equals to CS, that is a 24 upon 26 picofarad, that is 10 raised to minus 12 into applied voltage. So that is Q equals to 24 upon 26 into 10 raised to 10. Therefore, charge on every capacitor is nothing but 0.92 into 10 raised to minus 10 coulombs.